Hello students, welcome in another session of 12 Computer Science paper 2. Already we have started chapter 2, instruction set and programming of 8085 microprocessor. Now let us proceed this chapter, that is session 22. Students, in this video I am explaining in and out instruction of 8085 instructions or some machine control instructions. See, input, output, enable interrupt, disable interrupt, no operation and halt. Now let us see in detail one by one these machine control instructions. Now see, first instruction is input instructions. Okay. Now in this instruction, port 8-bit, input 8-bit data from an input port to accumulator. Port means, students, port means it is also in this port stored 8-bit data. Okay. Now what is the format? Whatever data stored in this port, that data stored or transferred to accumulator. See, whatever data stored in this port means port stored only 8-bit data. Always remember. So that data transferred to accumulator. Means what this instruction does, the current 8-bit content of the port, means whatever data available in port, that data transferred to accumulator. Means due to this instruction, transfer data to 8085 microprocessor through port, that is in accumulator, because 8085 microprocessor accumulator is there. Already you know this. How many registers in 8085? Accumulator B, C, D, E and HL. So accumulator register is also available in 8085 microprocessor. Addressing is direct addressing. Why it is direct addressing? Because all data directly transferred to accumulator. 2 byte is required to store the data in memory location. 1 byte is required to store 8-bit data and another 1 byte is opcode for input. Okay, so totally 2 byte is required to store the instruction in memory location. And this is a machine control group. No flags are affected because only transferring is there. No any calculations are done in this instruction. So nothing, any flags are affected. These instructions copies the data at the port whose address is specified in the instruction into the accumulator. Okay. Students, now what do you mean by port? See, just like you can say Mumbai is a port city. Why Mumbai is called port city? Because in Mumbai city is loading and unloading of ships. So Mumbai is called a port city. Now see, in technical language, data is transferred or received from which location? Means if 8085 microprocessor wants to data transfer to outside, that is in output device, means like monitor, screen, LED, these are the output devices, then always data transfer through port. If 8085 microprocessor receives the data from input device like keyboard, switches, then transferred through port, means port is only bufferizing. In this port, input or output data is as it is, means nothing change, means port cannot change the data. How to work this instruction? See, how to work this instruction, how to transfer data to accumulator. In this instruction, output switches is connected to port. and the port is connected to 8085 microprocessor. Means output switches cannot connect directly to the 8085 microprocessor, only through port. Always remember, students, in input instruction, whenever data is transferred to one location to another location, means port to accumulator or accumulator to port, at that time can't directly data transfer to processor. Always data transfer through these port. Whenever data transferred to output location or data received from input location, but always transfer through port, and port is like it store the means output, it like a switches, that switches is connected to processor or LEDs, whatever. If you want to data input or output, depends upon that instruction. Understood, student? What do you mean by port? Now see the example. See, port address is equal to 80H. See, what is the port address? 80H. Data stored as port address 80H is equal to 10H. Means 10H data is stored into 80H. Okay, means in 80H port stored 10H data. Now see, what is the format? Data is transferred to accumulator, means port is transferred to accumulator, means whatever data stored in this port, that data is transferred to accumulator. Now see, in 80H, see, in port is, what is the port address? 80H. Now in this port address stored 10H data. How to write this instruction? In 80 is port H. Now this instruction will copy the data, store the address 80H, that is data 10H in the accumulator. Means before execution, port address stored 10H data and accumulator stored nothing. Okay, see, port address stored 10H, accumulator is stored nothing. Now after execution, this in 80H instruction, port stored 10H and accumulator contains store 10H. Understood, student, how to execute this instruction? Okay, now see the next instruction, output. Opposite of input. Opposite of input. Just now we see this input instruction. In input instruction, data transferred to accumulator. Now in output, opposite of input means instruction output. In this instruction, data transfer from processor to output device like screen, monitor, LEDs. In this instruction, 8 LEDs are connected to 8085 microprocessor, but through port. Before that, we will see the address format of this instruction. See, accumulator, whatever stored in accumulator, that content transferred to address. Address means this is also called as port. This port is always in 8-bit format. Okay, so in previous instruction, port to accumulator. Now in output instruction, accumulator to port. Remaining are same, means addressing is direct addressing, byte is to byte, and this is a machine control group. No flags are affected because only transferring are done. So in this instruction sends the contents of accumulator to the output port whose address is specified within the instruction. Means see example. Before that, how to work this instruction, this output instruction, how to circuit in this instruction, just listen. In this instruction, LEDs, you know LED means light emitting device. In this instruction, 8 LEDs are connected to 8085 microprocessor, but through port. Means LEDs are not directly connected to 8085 microprocessor, always connected through port. because cannot connect it directly to processor, always connect through port. So using interfacing means interfacing IC is used to connect LEDs and processor, means between them one IC is used to connect these LEDs and processor. Data is transferred through data line. You know what is the function of data line and address line? Data line transfer data one location to another location. Same here. Data is transferred through data line, means data line of IC is connected to LED's data line, and then LEDs are connected to port, port data lines are connected to output, means processor. Okay, like this circuit is used for this output port. Now see example, in accumulator contains 40H. Now instruction is out 50H. What is 50? 50 is a port address, means whatever content in accumulator, that content transferred in the 50H port. Okay, means this instruction will send the contents of accumulator to the output port whose address is 50H. Now see, before execution port is 50H and accumulator contains 40H. After execution out 50H instruction, port address is that whatever stored in port address, means port address is 50H, whatever stored in accumulator, that data transfer into in port address, that is 50H. Understood student? Input and output instruction. Okay, now see, same as next instruction, this is also machine control instructions. See, enable interrupts. Now you know interrupts. Interrupts is a external signal that are interrupts to the processor. Okay, you know software interrupts and hardware interrupts. Hardware interrupts Chap, RST 7.5, RST 6.5, RST 5.5, INTR. These are the 5 hardware interrupts, and software interrupts is RST 0 to RST 7. These eight signals are software interrupts. Now in this instruction no operand. See here, see only AI is right. Okay, no operand is there. What is the format? Interrupt. E means enable, I means interrupt, means enable means 1, disable means 0. E stands for enable. Enable means active. Active means interrupt by make as a active stage. Okay, means RST 7.5, RST 6.5, RST 5.5. This is all interrupts, means all these interrupts are enabled. Means addressing is none, bytes is 1 byte. Okay, and group is machine control group. Flag is no flags are affected because only enable or disable interrupt. These instructions sets the interrupt enable flip flop to enable interrupts. When the microprocessor is reset or after interrupt, acknowledge. These interrupts enable flip flop is reset, and these instruction used to enable the interrupt. Okay, now student, interrupt enable means suppose any device are interrupt through these interrupt pins. Which interrupt pins? Suppose RST 7.5, 6.5, 5.5, these are interrupt pins. So suppose any device are interrupt through these interrupt pins, then microprocessor receive that interrupts, accept interrupts. Receive means accept that interrupt. If these interrupts are not execute or interrupt may be occur, then 8085 reject that interrupt. Reject means cancel. Okay, suppose see one more example in daily life. Suppose you are working something and same at that time someone is calling you, then you are maybe two action. If you are receive or you are cancel that phone or reject that phone. Okay, call means at that time you can receive call or reject call, means you cannot accept call means automatically reject it. or if you want to accept, then it means you can enable it. Same like here, suppose you want to accept interrupt, then interrupt pin is make enable. Okay, if you want to interrupt and accept the interrupt, at that time this pin is always first enable, then accept. You can accept means processor accept that interrupt signal. Okay, so it is called as interrupt, enable interrupt. Now next instruction is disable interrupt, opposite of enable interrupt. This interrupt performs means 0, disable means 0. These pins performs all interrupts are disabled. Addressing is none, byte is 1 byte, group is machine control. No flags are affected because only enable or disable interrupts. So this instruction resets the interrupt, enable flip-flop to disable interrupts, and this instruction disable all interrupts except trap. Trap is a non-maskable interrupt, cannot enable or disable. You know non-maskable or maskable interrupt. Already we have seen in previous videos, okay, at the hardware interrupt. Okay, so students, in this instruction, all interrupt, these instructions perform all interrupts are disabled. After execution of this instruction, the interrupt system is disabled. If once the interrupts are disabled and some interrupts are occur, at that time processor can't accept that interrupts. Okay, understood student? Disable interrupt. Now next instruction is NOP. NOP, N means no, OP means operation, no operation. This instruction addressing is none, byte is 1 byte because opcode is used for store the NOP opcode. Group is machine control, and flag, no flags are affected. Now when this instruction also used for stop the microprocessor, means stop the microprocessor or stop the program execution, but this instruction is used for delay instruction. Means in program we use loop instruction and we want to generate delay, so this instruction is used for time delay instruction. Means when this instruction is executed, no operation is performed, only this instruction is fetched or decoded, and these instructions do not affect flags or content of register. Means if this instruction is executed, then can't change in flag contents or register content, or this instruction is only used for time delay instruction. Okay student, now next or last instruction is HLT. Now you know very well this HLT. HLT means halt, halt means stop, means stop the processor. It does not, this instruction is 1 byte instruction, okay, and no flags are affected. This instruction halts the processor. It can be restarted by a valid interrupt or by applying a reset signal. Means if you can, whatever which instruction is used, suppose RST0, RST1, RST7, then restarted means again back to that program, back to that address, program counter goes to that address. Okay, so it is called as restarted by valid interrupt. This instruction halts the processor, means stop the processor, and this instruction, it does not exchange or not affect register content or flag content. Understood student? Okay, input, output, enable interrupt, disable interrupt, no operation, and halt instruction. Now this is the end of session 22. Thank you student.